Product is available as a open virtual appliance. It's a OVA file and it has to be installed on a VM under VMware vSphere environment. So it says, so deploy the NetEdits. Assume these two firewalls are acting as autonomous system boundary routers of this OSPF area 0 and both connected to the external network. In order to have one firewall see both directions of the traffic, we need to manipulate OSPF cost so that one firewall is preferred as primary path. So the strategy here is to have same cost from both firewalls for external routes and keep the internal cost, that is cost to the SBR, should define external type 2 routes for the external routes using a different initial cost value for each SBR. Yes, this is what we have discussed. This is correct. Option C. Both SBRs should define external type 2 routes. Hello everyone. Welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Switching Professional Exam. In this session today, you will understand few concepts related to Aruba wired solutions. Before I move on, let me introduce the 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be covering few topics such as configuring wired network solutions, troubleshooting, management monitoring and optimization, and planning of Aruba wired solutions from Aruba Certified Switching Professional Exam objectives. Let me briefly go through each one of them. Under configuring wired solutions, topics related to configuration of layer 2 and layer 3 functions and features related to security, key voice, and how to build configuration based on customer requirement are included. Then troubleshooting includes how to identify a network failure, how to determine implications on network state due to the remediation actions taken, and how to determine the cause of performance problems. Management monitoring and optimization covers the configuration management and how to analyze data that represents the operational state of a network. Determining an appropriate implementation plan based on design or customer requirement is covered under planning. Okay, let's look at the sample question under configuring wired network solutions. An access layer AOS-CX has no QoS configuration on it. The switch receives an 802.1q tagged VoIP frame on a port. The frame has an 802.1p value of 6. The IP header has a DHCP value of EF46. How will the switch forward this frame? The question is about how the AOS-CX switch treats the VoIP traffic without any QoS configuration on it. If there is no configuration on the switch, then default QoS trust mode is none. Therefore, even the 802.1p value and the DHCP value are set, switch will ignore them, and local priority values are assigned from the COS map value to code point 0. Look at this image from Aruba documentation. Here you can see when the QoS trust mode is none, that is the default setting in the AOS-CX switches. So even the tagged with DHCP value of 32 and PCP equals 3, but still it will assign the local priority of 1 and COS map to 0, because it will ignore the previous set values. So this is the default behavior of QoS in AOS-CX switches. So let's look at the answers. Option A forwards it based on the 802.1p value in the frame. No, 802.1p value is ignored because default QoS trust mode is none. This is wrong. Option B forwards it based on the DHCP value in the frame. No, DHCP value is ignored because default QoS trust mode is none. This is also wrong. Option C places it in the high priority queue. No, local priority of 1 will be assigned, so won't be placed in the high priority queue. This is wrong. Option D forwards it as a normal frame. Yes, it will be forwarded as a normal frame with local priority 1 and COS map 0. This is correct. Therefore, correct answer is option D. Take a look at the next question under configuring wired network solutions. A network administrator is implementing BGP for a large network. The network has over 20 exit points across 15 different BGP routers. The administrator does not want to implement a fully meshed IBGP peering between all BGP routers. Which feature should the administrator implement to reduce the number of peers the administrator needs to define? Need to discuss a little bit on IBGP. Due to the BGP split horizon rule within IBGP, all IBGP peers within an autonomous system must be fully meshed, because any routes learned from an IBGP neighbor must never be advertised to any other IBGP neighbor. So in this question, administrator does not need to implement fully meshed IBGP peering between all BGP routers. Look at this image. One solution to reduce the number of BGP peering within an AS is route reflection. Rather than each BGP router having to peer with every other BGP router within the AS, each BGP speaker instead peers with a route reflector. So routing advertisements sent to the route reflector are then reflected out to all of the other BGP speakers. Then the number of IBGP peering gets reduced within the AS. So this is what this image explains. So you can see on my right side there's a route reflector. So all the BGP speakers are sending route advertisements to the route reflector. So unlike the left hand side, so you are reducing the number of BGP peering. We'll go through answers. Option A, route reflectors. Yes, this is what we have discussed. This is correct. Let's check the other options as well. Option B, next hop self. Next hop self command configures the router as the next hop for a BGP speaking neighbor or peer group and enables the BGP to send itself as the next hop for advertised routes. This command is useful in non-meshed networks where BGP neighbors may not have direct access to all other neighbors on the same IP subnet. But this is not a solution to reduce the IBGP peering. So this is wrong. Option C, BFD, bidirectional forwarding detection. It provides a general purpose, standard, protocol independent, fast failure detection mechanism. It can detect and monitor the connectivity of links in IP to detect communication failures quickly. BFD operates independently of media, data protocols and routing protocols, but it doesn't reduce the number of IBGP peering between BGP routers. So this is not correct. Option D, peer groups. A BGP peer group reduces the load on system resources by allowing the routing table to be checked only once and updates to be replicated to all peer group members instead of being done individually for each peer in the peer group. Since it doesn't reduce the IBGP peering between BGP routers within the AS, it is wrong. So correct answer is option A. Okay, we'll move on to the next question, troubleshooting. The company has just upgraded their access layer switches with AOS CX switches and implemented an AAA solution with ClearPass. The company has become concerned about what actually connects to the user ports on the access layer switches. Therefore, the company is implementing 802.1x authentication on the AOS CX switches. An administrator has globally enabled 802.1x and has enabled it on all the access ports connected to user devices, including VoIP phones, security cameras, and wireless Aruba IAPs. Wireless users are complaining that They successfully authenticate to the IAPs, however they do not have access to network resources. Previously this worked before 802.1x was implemented on the ARCX switches. What should the company do to solve this problem? Here we have to focus on what change that 802.1x brought into the switch that disturb wireless clients. Let's look at the Aruba documentation on this. When you implement 802.1x on ARCX switch ports, there are two modes that you can choose to configure. They are device-based mode and client-based mode. By default, client-based mode is in effect with the maximum client limit as 1. In client-based mode, all clients connecting to the port are sent for authentication. In device-based mode, only the first client connecting to the port is sent for authentication. Once this client is authenticated, the port is considered as open and all subsequent clients trying to connect on that port are not sent for authentication. In this question, IAP itself is responsible to handle the authentication. So it would perform 802.1x authentication with the wireless clients. But then the traffic is forwarded as regular traffic on the switch port. So the switch would also attempt to perform authentication of this client. Since the 802.1x traffic of the client is terminated at the IAP, the switch would attempt to perform MAC authentication for the client MAC address. So for this scenario, it is required to configure the switch ports connecting to IAPs in device-based mode. We will go through answers. Option A. Implement device-based mode on the IAP connected AOSCX switch ports. This looks correct as we have discussed the same. Option B. Implement local user roles and local forwarding on the AOSCX switches. Here there is no effect of configuring local user roles in the switch to resolve an issue of wireless clients. This is wrong. Option C. Implement downloadable user roles and user-based tunneling on the AOSCX switches. There is no mobility controller or gateway here to terminate user-based tunnels. So this is wrong. Option D. Implement AAA radius change of authorization on the AOSCX switches. Radius change of authorization would be used to change the VLAN assigned to the switch port, but it will not solve the wireless client issue mentioned in the question. So this is wrong. Correct answer is option A. Let's look at the next question under troubleshooting. An administrator is managing a network comprised of AOSCX switches deployed at the aggregation layer. The switches are paired in a VSX stack and run the OSPF routing protocol. The administrator is concerned about how long it takes for OSPF to converge when one of the VSX switches has to reboot. What should the administrator do to speed up the OSPF convergence of the switch that is rebooting? Okay, question is about the OSPF convergence and how to speed up. When you think of mechanisms to speed up the OSPF convergence, then OSPF graceful restart is the feature comes into the mind. Okay, look at this Aruba documentation on graceful restart of OSPF routing. Graceful restart allows a routing device undergoing a restart to inform its adjacent neighbors and peers of its condition. During a graceful restart, the restarting device and its neighbors continue forwarding packets without disrupting network performance. So OSPF routing can be gracefully restarted on the switch without losing packets that are in transit. OSPF neighbors are informed that the router is completing a graceful restart, which allows for maintenance on the switch without interrupting traffic in the network. There is no effect on the saved switch configuration. So this is what Aruba documentation says. There are a few steps you need to complete to configure a graceful restart on the AOSCX switch. On AOSCX switches, graceful restart itself is always enabled and cannot be disabled. Graceful restart helper is enabled by default but can be disabled. However, you can adjust the graceful restart timer and enable or disable the helper function. Okay, look at the answers. Option A. Change the VSX ISL link from an OSPF broadcast link to point-to-point. It doesn't matter whether it is broadcast or point-to-point. No impact on OSPF conversion speed. This is wrong. Option B. Decrease the VSX initial synchronization timer on the two VSX switches. VSX synchronization timer will affect on the synchronization of configuration changes, but not the OSPF conversion speed. This is wrong. Option C. Implement graceful restart on the VSX switches and their neighboring OSPF switches. This looks correct as we have already discussed the same. Option D. Define non-backbone areas on the VSX switches as totally stubby areas. Totally stubby areas will reduce the number of LSAs going into the non-backbone areas because only the default route is injected. But it will not affect the OSPF conversion speed of the aggregation switches. So this is not correct. Correct answer is option C. Next question is from Management, Monitoring and Optimization. The AOS-CX mobile app allows a network engineer or technician to perform which tasks? You have to select two answers. Let's understand the capabilities of AOS-CX mobile app. The CX mobile app is an application to provision a CX device. Aruba CX mobile app connects to CX switch using supplied Bluetooth dongle. Each AOS CX switch comes with Bluetooth dongle when you order a new switch. These are some sample screenshots of the AOS CX mobile app. So using CX mobile app, you can configure basic operational settings and it eliminates having to connect a terminal emulator and cable to the console port. So without cabling to the console port, you can just connect to the switch via Bluetooth using this AOS CX mobile app. There are built-in configuration templates, or able to customize and use your own templates as well. And you are able to easily view and change the configuration of individual switch features or settings. And even you can manage the running configuration and startup configuration of switches. And you can perform file transfer between the switch and your mobile device. And also you can share configuration files from your mobile device, and you can copy the running configurations to the startup configuration. Also you can access the switch CLI through the mobile app, and you are able to check the PoE budget and utilization on switches to see available capacity as new PoE devices are added. And you can auto detect the potential stack members and stack links. So you are able to do VSF configuration using few clicks. On this image you can see on the right side there's a VSF stack is set up. And it also allows a switch with an HTTP server connection to easily download the latest firmware. And you are able to integrate with Aruba NetEdit, and then it provides intelligent configuration management, continuous conformance validation and overall network health. Okay, now you got a lot of information on capabilities of AOS CX mobile app. Okay, let's go through answers. Option A. Use NetEdit to manage switch configurations. Using AOS CX app, you can integrate the switch with NetEdit. Then NetEdit can manage switch configuration, but AOS CX app is not using NetEdit to manage configuration. So this is wrong, because the option A says use NetEdit to manage switch configurations. But AOS CX app is not using NetEdit to manage configuration. It only allows to integrate the switch with NetEdit. So option A is wrong. Option B. Transfer files between the switch and your mobile device. Yes, you can do file transfer between the switch and your mobile device. This is correct. Option C. Schedule an operating system upgrade. You can allow the switch to download the latest firmware, but you cannot schedule the upgrade. This is wrong. Option D. Create a stack of AOS CX switches. Yes, able to create a VSF stack of AOS CX switches. This is correct. Option E. Securely access the switch using SSH. You can access the switch through CLI via mobile app, but it is not equal to the accessing the switch via SSH. So this is wrong. Correct answers are option B and D. Let's move on to the next question under management, monitoring and optimization. How is NetEdit installed at a customer location? This is related to NetEdit installation. Aruba NetEdit provides automation of search, edit, validation, deployment and audit for network configurations. It provides intelligent assistance and continuous validation to help verify device configurations are consistent and compliant while reducing the chance of errors. Let me open the NetEdit installation guide. So this is the Aruba documentation on NetEdit installation. So this product is available as a open virtual appliance. It's a OVA file and it has to be installed on a VM under VMware vSphere environment. So it says, so deploy the NetEdit server OVA through the VMware vSphere web client interface. So it's very clear now. So it's a OVA file and it has to be in vSphere server environment. Let's look at the answers. Option A, via Aruba Central Cloud Solution. No, it is not installed via Aruba Central. This is wrong. Option B, via an Aruba NetEdit hardware appliance. No, there is no Aruba NetEdit hardware appliance because NetEdit is available as an OVA file. This is wrong. Option C, via a DVD using a virtualized platform like Microsoft Hyper-V. It doesn't support Microsoft Hyper-V. It has to be installed in VMware vSphere environment. This is wrong. Option D, via an OVA file and a virtualized platform like VMware's ESXi. Yes, this is correct. Therefore, the correct answer is option D. Next question is under planning and wired network solutions. An administrator is configuring BGP and has two connections to a service provider to two different local routers. Which BGP metric should the administrator configure to influence which local router the service provider will use to reach certain routes? Let's visualize the setup. So there's a service provider router and you have two local routers. And they are running eBGP with the service provider. There are two connections to the service provider. This is service provider and this is eBGP. And you have LAN here in the site. So you have various subnets to advertise. So these are eBGP connections. So it's a different AS number here and another different AS number here. Now administrator has to do some configurations here on these are local routers on the site so that it can influence the service provider router to reach the particular local subnet. So let's say there's subnet A and another subnet called B. These are subnets to be advertised through BGP. Let's say this is R1 and this is R2. Actually, there are two methods. They are AS path prepending and manipulation of the MED value, which is multi-exit discriminator. Let's look at the first method. When you advertise local subnets towards the service provider, then you can advertise certain subnets via BGP on one router. Let's say we want to prefer R1 to reach insight from the service provider, then we can advertise longer AS path through R2 to reach, let's say, for example, subnet A. So when the service provider sees the longer AS path through R2 to reach subnet A, so it will not prefer R2. So it will prefer the R1 who is providing shorter AS path to reach subnet A. So that is one method, AS path prepending. The second method is When you advertise subnets through BGP via one router, assign lower MED value for certain subnets. Let's say R1 is sending lower MED value. Okay, so MED value for the subnet A is low. For the same subnet A, R2 is providing higher MED value. So R2 is providing higher MED value for the same subnet. So service provider will prefer the lower MED value. So service provider will prefer R1 to reach subnet A because R1 provides a lower MED value when it advertises subnet A to a service provider. So hope you got the idea now. Let's look at the answers. Option A, multiple exit discriminator. This is correct, as we have already discussed about it. Option B, origin. Origin attribute, actually the path with the lowest origin type is preferred. Origin types are preferred in this order: IGP, EGP and incomplete. So the first preference is for IGP, that is subnets advertised via network command in BGP. Second preference is for EGP. EGP means exterior gateway protocol, that is routes obtained via BGP. Third preference is incomplete, that is routes redistributed from other routing protocols. But it is not possible to influence the path for required subnets in this way, because in both routers, subnets are advertised in BGP using network command. So both routers show them as IGP. So this is wrong. Option C, weight. Weight is local to the router and it is used to select the path with highest weight for outgoing traffic from local router towards the service provider. Question is asking to influence the service provider to select the specific path for incoming traffic to the client side. This is not correct. Option D, local preference. Local preference is also used to select the path for outgoing traffic from local router towards the service provider. This is not correct. Correct answer is option A. We have reached the final question under planning via network solutions. A network administrator is implementing OSPF where there are two exit points. Each exit point has a stateful application inspection firewall to implement company policies. What would the best practice be to ensure that one firewall will see both directions of the traffic, preventing asynchronous connections in the network? Let's visualize the setup and focus on the ASBRs in OSPF and external type 1 and type 2 routes. Assume these two firewalls are acting as autonomous system boundary routers of this OSPF area 0 and both connected to the external network. In order to have one firewall see both directions of the traffic, we need to manipulate OSPF cost so that one firewall is preferred as primary path. So the strategy here is to have same cost from both firewalls for external routes and keep the internal cost, that is cost to the SBR, for manipulation. So external type 1 route is not suitable for this because it has combined cost of external and internal. Therefore need to define the external type 2 routes in both ASBRs so that external cost is same in both ASBRs. Then define different initial cost value for each ASBR so that lower cost path will be preferred as primary for a particular external route. So both the ASBRs will have same type 2 external cost, and since we have configured different initial cost in, let's say we want to make this ASBR1 as primary path, so we can configure lower initial cost ASBR for the internal side. So then ASBR1 is preferred always for the outgoing traffic for that particular external network. Let's check the answers. Option A, Both ASBRs should define external type 1 routes for the external routes using a different initial cost value for each ASBR. External type 1 would not be suitable because it provides combined cost of external and internal, so that it's not possible to control the primary path. This is wrong. Option B. Both ASBRs should define external type 2 routes for the external routes using a different initial cost value for each ASBR. Yes, this is what we have discussed. This is correct. Option C. Both ASBRs should define external type 2 routes for the external routes using the same initial cost value for each ASBR. Using same initial cost value won't make any cost differentiation and cannot make primary path. This is wrong. Both ASBRs should define external type 1 routes for the external routes using the same initial cost value on each ASBR. External type 1 would not be suitable. So this is wrong. So the correct answer is option B. That concludes our training for today. I hope you found this overview of Aruba Certified Switching Professional exam topics helpful. We have discussed sample questions covering the areas such as configuring wired network solutions, troubleshooting, management monitoring and optimization, and planning wired network solutions. Be sure to check out 591lab.com for more online courses, practice exams, and training materials to continue your certification preparation. You can also visit www.591cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class, and I wish you the best of luck on your certification journey. Have a great day.